All right, today we're working on Chapter 4, Section 3, which is prime factorization and greatest common factor. So first let's go through some examples of what a prime number is, because in order to do prime factorization, you have to know what a prime factor is. So let's look at this part right here. First of all, a prime number can only be positive numbers. So 1, 2, 3, 4, all the way up. A prime number has exactly two factors, no more, no less. The factors are the number 1 and then the actual number. So let me show you what I mean here with the examples. 2 is a prime number because you can only have the factors of 1 times 2. The factor is 1 and the factor is the number itself. That's why it's prime. Same thing with the number 3. 1 times 3. Those are the only two factors of 3. There's nothing else. 2 is not a factor of 3. And then for 5, 1 times 5. So those are prime numbers because they are only divisible by 1 and themselves. Okay, now a composite number is basically any number that's not prime. Again, it can only be positive numbers, but composite numbers have more than two factors. So let's take a look at the number 4. You can have 1 times 4, or you could have 2 times 2. So it has more than two factors. For the number 3, you could have 1 times 6. Let me change colors, or you can have 2 times 3. Remember how we did the factors the other day. And then for 8, you can have 1 times 8. You can have 2 times 4, and that's it. But there are more than two factors. For 4, we have 1, 2, 3 factors. For 6, we have 4 factors, okay? So that's the difference between a prime and a composite. All right, so now when we do prime factorization, what we want to get to is we want to get down so that all we have are prime numbers. Let me show you what I mean here with 72. When you think of prime factorization, think of a factor tree. Your factor tree is where you separate it like that, if you remember doing this in elementary school. So what you want to ask yourself are, what are two numbers that I can multiply by each other to get 72? Well, we could multiply 9 times 8. Now there's many different ways, and I'll show you that on the next slide, but I chose 9 and 8 because 9 times 8 is 72. When you get to a prime number, you want to circle it. However, 9 is not prime, 8 is not prime, so I'm not done with either one yet. That means I need to break down 9 into two numbers that can multiply by each other to equal 9. Well, the only two that can do that, besides 1 and 9, you don't want to do that, you could do 3 times 3, and that would be 9. Now since 3 is a prime number, I'm going to circle that because I can no longer go any further. And obviously this 3 is also prime, so I circle it. Now let's look at 8. We can break down 8 into 2 times 4. 2 is a prime number, so I circle it. 4 is not a prime number, so I need to break it down even further. What times another number can equal 4? 2 times 2 can equal 4. These are both prime, so I circle them and I'm done because there's nothing else that I can continue with. Now let me show you what this really means. Let me show you on my calculator here. The numbers that I circled, if I multiply them, will equal 72. So if we multiply 3 times 3 times 2 times 2 times 2, we get 72. All we did was we broke down 72 into the prime numbers that you have to multiply in order to get 72. Now I said before that you can do this more than one way, and I want to prove that to you. So let's look at the next slide here. This is the way we just did it. 3 times 3 times 2 times 2 times 2. That was in the last slide. The 4 and the 2 were switched. I think I did that opposite, but it's the same thing. So now let's look at 72 and do a different way. We could do 12 times 6, because 12 times 6 is 72. And now we can break these down. Neither of these are prime, so I need to break down 12. I could break it down into 3 times 4. 3 is prime, so I circle it. 4 is not prime, so I need to keep going. Well, that would be 2 times 2. 2 is prime, so I circle those. Now let's go to 6. It's not prime, so I need to keep going. 6 can break down into 2 times 3. 2 is prime, 3 is prime. Okay, there's nothing more that I can break down, so I'm done. Notice we got the same thing here. We have a 3. How many 3's do we have here? 1, 2. And then we have a 2, 2, 2. Well, that's the same thing we have here, 2, 2, 2. So it doesn't matter which way you do it, you get the same answer. Now let me show you how you would write this. If they ask for prime factorization, remember you're just multiplying these out. So we could say 3 times 3 times 2 times 2 times 2, but we learned yesterday that we can use exponents as a shortcut to writing out all this multiplication. So what is my first base? My first base is 3. How many times did we multiply 3? 2 times, so that would be 3 squared. My next base is 2. I need to put times in here. 2, how many times did we multiply 2? 1, 2, 3, so that would be 2 to the third power. Now you can check that. If you type in your calculator 3 squared times 2 to the third power, it will equal 72. That's the prime factorization of 72. Let's try another example. 121. Prime factorization. 121 is not prime, so I need to find two numbers that can be multiplied that equal 121. Well, I know that I can multiply 11 times 11. Is 11 prime or composite? 11 is actually a prime number because the only factors are 1 and 11. There's nothing else that you can multiply to get 11, so that means that I'm done. I circle my 11s, so the prime factorization of 121 is 11 squared. Done. Okay, what if I tell you to find now the greatest common factor? To find the greatest common factor, first you have to do the prime factorization of both numbers. So let's do the prime factorization of 40. We could, like I said before, there's many ways, but I'm going to do 4 times 10. Neither of these are prime, so I need to keep going. I could break this down into 2 times 2. These are both prime, so I'll circle them. And then for 10, I could break that into 2 times 5. 2 is prime, 5 is also prime, so I circle them. So that would be 2 times 2 times 2 times 5 equals 40. Now let's do the prime factorization of 60. Again, many ways, but I could do 6 times 10. Neither of these are prime, so we need to keep going. 6 can break down into 3 times 2. 3 is prime, 2 is prime. 10 could break down into 2 times 5. 2 is prime, 5 is prime. Now what I did on the next slide is I just listed them in order. It's the same thing we just got, but I wanted you to see the side-by-side comparison. Because now in order to find the greatest common factor, what we have to do is figure out what these have in common. So whatever matches, I'm going to circle. Okay, so they both have a 2. They both have another 2. This is a 2. There's no more 2's for the 60, so I don't circle that one. This is a 3. There's no 3's for the 40, so I don't circle that. But then they both have 5, so I circle that. So what they have in common is 2 times 2 times 5. In order to figure out the greatest common factor, I need to multiply these numbers. So 2 times 2 is 4, and then 4 times 5 is 20. That means that the greatest common factor for these two numbers is 20. Let's do one more example like this, except now we're going to do it with variables as well. So to find the greatest common factor of 6a to the third power b and 4a squared b to the third power, I need to list out my prime factorization. So for 6, that would be 3 times 2. That's all I need to do because those are both prime. And for 4, that would be 2 times 2. and these are both prime, so I'm done already. Then when I'm writing out a to the third power, I'm just going to write a times a times a, and then b would just be 1b. That's it. And then over here, a squared is a times a, and b to the third is b times b times b. So now here's the prime factorization for both of those. I listed it all out in order on the next slide so you could see it. And now we've got to circle what they have in common. They both have a 2. They both have an a. They both have another a. They both have a b. And that's it. There's nothing else that they have in common, so I'm done there. So now I list these out. 2 times a times a times b. That's what they have in common. So to write that with exponents, it would be 2 times a squared, because I have 2 a's, times b. That's the greatest common factor of these two numbers. That's it for today, guys. Bye-bye.